Hello everyone. Today we are going to present our project that is evaluating CryptoNetRoute protocol for wireless sensor network security in dynamic environment. Today me, Shruti Nair, along with my teammates Chaitanya Bandi, Srinidhi Mavuri and Akansha Gurudu are going to present this. Okay, next slide. Coming to the introduction, in our hyperconnected society, data security is more crucial than ever. Our information is constantly flowing through networks, and protecting it from cyber threat is paramount to maintain confidentiality, integrity, and authentication. So, we rely on a traditional routing protocol to ensure the security of our data. They have served us well, but as the technology advances, so do their two threats. We need solutions that can stand up to the emerging challenges. So today's cyber threats are sophisticated and ever evolving. We can't afford to compensate those. This is where our research paper comes into play. So our team is dedicated to developing a robust solution for securing routing protocols, and we recognize the need for enhanced measures to counteract the growing complexity of cyber threats. Also, our research aims to address three critical aspects. Those are confidentiality, ensuring our data remains private, integrity, maintaining the accuracy and reliability of our information, and authentication, also verifying the legitimacy of data sources. In response to all these challenges, our research mainly focuses on developing a cutting edge solution that go beyond the capabilities of traditional protocols. We also aim to create a robust defense against the current and future cyber threats. Okay, next slide. Okay, so what exactly is CryptoNetRoute? Our digital landscape is constantly evolving with it. It's the challenge to secure communication. Existing solutions, while effective to a certain extent, some come with limitations. As we embrace more interconnected and sophisticated technologies, we encounter new and emerging challenges in the data security. In face of these challenges, there are growing need for advanced approaches in secure communication. We require solutions that not only addresses current limitation but also anticipate and counteract future threats. And this is when our CryptoNet route comes into play. This is a novel protocol that is designed to evaluate the standards of secure communication, and it goes beyond the capabilities of traditional solutions by integrating cryptographic tricks by enhanced security. CryptoNet route is just not a protocol, it's a paradigm that is shifted to a secure communication. Also, this is not just about encryption, it's about leveraging cutting edge technology to a entire communication process. Our CryptoNet route doesn't need much security standards because it exceeds all of them. With robust cryptographic mechanism, it ensures confidentiality, integrity, and authentication level. Our protocol that we used isn't a small fits, it fits all kind of solutions. It's tailored to address specific challenges and prevalent in modern communication landscape, which provides a comprehensive defense against all the cyber threats. From secure IoT communication to safeguarding the sensitive data in cloud environments, the applications are diverse and impactful. Okay, can you go to the next slide? Okay, so our journey began with layered protocol design. It's nothing but architectural blueprint for effective and clear structure of our system. Each layer net serves like a specific purpose, contributing to the overall functionality while maintaining a well-defined structure. The benefits of layered design is nothing but it compartmentalizes the function, making the system more manageable. It changes or updates one or more layer, which doesn't require affecting any other layers. And coming to the second one, that's decomposition of services. This is where we apply a modular organization for functionality. Instead of having one monolithic structure, we break down services into smaller, more manageable modules. This is not only simplifying the development but also enhancing the flexibility. Some of the advantages are each block serves as a unique purpose. You can rearrange them to create various structures. Similarly, service decomposition allows us to mix and match functionalities by adapting to the changing requirements. Also, we implement hash functions in Contiki, which is a light operating system for the Internet of Things. When implementing hash functions in Contiki, we start by incorporating essential Contiki headers. These headers are necessary to framework for communication and resource management within the Contiki OS. For robust security, we include the vital SHA-256 header. This header brings the secure hash algorithm 256 bit into play, ensuring the integrity and authenticity of the data within our system. SHA-256 isn't just a random choice; it's a bit length provides which a high level of security, which making it resistant to various cryptographic effort. This is an ideal choice for ensuring the integrity of our data. Next slide. Next slide. Okay, these are the diagrams of the layered protocol and the decomposition. So that's it. And from now, Akansha will be explaining.
Yeah, please go ahead. Next slide. So this is the simulation results. There is this red arrow pointing from node 2 to node 1, and this blue arrow pointing from node 6 to node 2, indicating the sequence of the packet transfer or the route taken for a specific simulation scenario. This kind of simulation is critical for visualizing and analyzing the behavior of network protocols and the flowed data in a controlled environment. So can you move to the next slide, please? So here is a simulation control. Here we took the speed of 280.86, which means approximately 2.8 times the normal speed. This might be used to speed up the simulation process to quickly reach a particular state or to analyze behavior over a long period without any real-time delays. So that's the reason we use this thing. So can you move to the next slide? Coming to MAC is used to verify that a message has not been altered in the transit. The MAC values are typically computed using a secret key in the combination with message, and the integrity of the message is verified by recomputing the MAC on the receiver end and the comparing it to the one sent with the message. So the as you see on the screen, the message is this, and this is the hash value. So when it's transferred from the sender to the receiver, they will be encoded with this hash value, so that the message must not lose. So that's the main thing, the main role of this MAC, and the integrity is the thing, and this is the hash result. So this is how the message will be delivered to the receiver once he receives the message. Can you move to the next slide? So in this we had used two approach implementations. Like there are mainly two implementations. One is key establishment implementation, and another is routing protocol message implementation. So ECG key generation algorithm in this is a public key uh, cryptography. This algorithm is essential for generating random private key, the key establishment. And then ECC key exchange algorithm is also mentioned, which is used to facilitate secured communication by computing shared secret point between parties, enabling private information exchange over a public medium. So when it comes to routing protocol messages, describes the structure of the crypto net routes, packet structures, and ensures that the communication is secure. It details the inclusion of fields in the packet structure for maintaining confidentiality, integrity, and authentication. The security fields of these packets are implemented using cryptographic primitive like AES, which is Advanced Encryption Standard, and SHA-2 secure hash algorithms. So these are some kind of algorithms which they used internally when it comes to routing protocol messages. These cryptographic mechanisms are interwoven into routing protocol message to safeguard the data being transmitted in the network. So basically, these two implementations are used to make sure that the message has delivered to the receiver without any discrepancies. So these algorithms are used. Yeah. From here, Akansha will continue.
Here, the flowchart shows how CryptoNetRoute protocol manages routing and data handling in a network stack. At the app layer, the route process handles routing paths, data processes prepares data, and the corresponding service processes support encapsulation and routing info. The network layer's dispatcher process directs packets to route forward process for routing or data forward process for data. These processes use a message pool and up.send function and up.receive function facilitates packet movement between layers, ensuring efficient and secure data routing in a modular approach. Can you move to the next slide, please? Routing discovery algorithm. This algorithm establishes communication path efficiently and intelligent assessment finds direct routes. The route request packets ensure security and the route reply packets assess performance. And the route maintenance algorithm, it keeps the network robust, continuous route verification and secure refresh prevent breaches. Dynamic route adaptation and reactive route repair offer stability. Security is integrated at every step for data integrity and privacy. Together, these algorithms maintain a reliable, secure, and efficient communication infrastructure, adapting to growing data transmission demands. Can you move to the next slide? Here, um, configuring the environment, set parameters for real world simulation and customize test, integrate CryptoNet route source code, compile and deploy to Koja nodes. Coming to the simulation scenarios, assess Benin and attack scenarios for protocol effectiveness. Metrics include a packet delivery ratio, which is PDR, end-to-end delay, E2E delay, which is E2E delay, and routing overhead, RO. Measure security through number of attacks detected, NAD, and number of attacks mitigated. Uh, Coming to the next slide. So we evaluate network performance through these key metrics. Packet delivery ratio with high PDR ensures reliability. End-to-end delay measures average packet travel time, crucial for time-sensitive applications. Routing overhead. Lower overhead indicates a more efficient network. And number of attacks detected and number of attacks mitigated assess network security against malicious activities, and simulation results provide real world insights showcasing outcomes under various scenarios, which are essential for understanding protocol performance. Can you go to the next slide, please? So here are the results of the simulation experiments of packet delivery ratio, end-to-end delay, and routing overhead, number of attacks detected and mitigated. And can you move to the other slide? From here, my friend Srinidhi is going to continue.
Yes, in this slide, we are going to discuss about the performance of CryptoNetRoute in benign scenarios. So as we see a very high PDR, that is a packet delivery ratio of around 99.8%. So this means that almost all of the packets are getting through, and the E2E delay, that is the end-to-end delay, is also very low at just like 10.2 milliseconds. This means that all the packets are reaching the destination pretty quickly, and the RO, which is routing overhead, is low at 1.5%. So this means that not all the packets are being used for routing overhead, and this is good because it means that more bandwidth is available for the actual data. And so overall, from this table, we can conclude that the network is performing pretty well, and the packets are being delivered quickly and with very little overhead. And coming to the next slide. Yep. So here, as this table basically shows the result of three different attacks on the network. that are black hole, wormhole, and Sybil. So the black hole attack in the black hole attack, so basically it is designed to make a network resource unavailable to the users, and in this case, this attack was pretty effective with a PDR of only 2.0 percentage, and the E2E delay was also high at 12.3 milliseconds, and the RO was 100%. So this means that basically the whole network was that almost all of the packets were lost, and that the attack took all of the available bandwidth, and the NAD and NAM values are both 100, which indicates that the attack was able to successfully deceive the network about the attacker's address and mask the attacker's address. So coming to the next attack, that is wormhole attack. So basically, here we create a covert channel between two attackers, and in our case, the attack was also effective with a PDR of only 1.8 percentage, and a E2E delay was slightly lower than the black hole attack at 1.5 milliseconds, and the RO was 100%, and the NAND and the NAM values were both 100. So this indicates that the attack was able to successfully deceive the network, and the address and the mask and the attacker's addresses. Uh, Coming to the next attack, that is the cyber attack. So here, basically, this attack is used in order to create multiple fake identities on a network. And in our case, this particular attack was very effective as well, with a PDR of 1.6 and an E2E delay of 10.8 milliseconds and RO at 100%. So this indicates that the attack was successful. So overall, this table shows that all the three attacks were successful in our network, but the most effective was the black hole attack in terms of packet delivery, whereas the Cybele attack was most effective in terms of end-to-end delay. So all over, the three attacks were able to completely take over the network's routing overhead. Coming to the next slide regarding the discussion and the implementations. While discussing first about the comparison with non-secure baselines, with a non-secure baseline, the CryptoNet route exhibits a superior performance and notable security enhancement, as evidenced by a comprehensive comparative analysis. Despite incurring computational overhead, the protocol's efficiency serves as a compelling justification for its adoption. And coming to the next point, that is about the implication of the result. So the real world applicability and consequential impact of CryptoNetRoute are underscored by its ability to manageable trade-offs in resource consumption, showcasing practicality across diverse deployment scenarios. And the strength and limitations of crypto network includes its robustness and adaptability, highlighting its effective in addressing various security challenges. Coming to the next slide about the conclusion. So talking about the efficiency of our system. So our main goal is to make CryptoNetRoute work even better. And we are looking into using lightweight cryptography algorithms to make it perform more smoothly. And talking about the resilience and enhancement. So we are working on making our CryptoNetRoute stronger against tricky attacks and developing smart security features to make it bounce back quickly. And in the next is about the integration with cutting edge technologies. So we are further exploring new ways to make CryptoNetRoute even more powerful, and teaming up with technologies like blockchain and machine learning at using latest hardware tricks like secure enclaves for extra security. And the CryptoNetRoute stands out because it's really good at balancing strong security and working efficiently, so it performs well and keeps things secure, making it a trustworthy choice for a lots of different users. So thank you.